Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the final project, laser tripwire for the Raspberry Pi without the Raspberry Pi, or RPI, no RPI for short. A lot of this is stuff we've done before. When we import, these are our imports. We got play sound to play audio sounds, serial and time. We've used those all before. You guys all know this at this point. If you don't, there's a problem because we've used this function in every single previous project. It allows us to establish communications with the Raspberry Pi without the Raspberry Pi. We got our slicer function, which we've used before. Rewrite, which we've used before. We'll get to those. We'll go over them again in a second. We've got our main code here. So this is a loop. It'll loop forever while true. First sets x to 0. Then set x to 5 at the beginning of the loop. Set it to quote 5, so essentially a string. You got quotes around it, so it's a string. And what we're going to do is we're going to create a variable called value. Then we'll call write read, the write read function above, and send over x, which is a string of version of 5, which is 53 ASCII to the Raspberry Pi without the Raspberry Pi. And the return value read back from the MCU will be returned in value. So let's look above. We're sending over x to write read. And we're writing x to the Raspberry Pi without the Raspberry Pi, creating a global variable called data, and we'll say data equals the read back value from the Raspberry Pi without the Raspberry Pi, and we'll return data, which is returned in value. So data equals value equals data. We'll print the string version of the return value to the shell down here. Then we'll send over. We'll call the slicer function, send over the string version of value. It'll slice it up and return the sliced version into value. So let's look above. We're going to do some replacing. We're going to replace any B with nothing. We're going to get rid of any single quotes and replace it with nothing. If value does not equal nothing, then value is the integer version of value. So it's a number again, not a string, and it will return value. And that's right here. So then we're going to print the new string version of value, but it's not actually, the value itself is not actually a string. We're just going to print the string version of it. It's an integer, so we can say if value equals 0, we'll print to the shell. Someone has breached the laser, and we'll use play sound. Now, and we'll play. I've used Star Trek: The Next Generation's Red Alert. You need to come up with your own sound bite. It's just an MP3. Doesn't really matter what. If you have trouble using the play sound library from this code, go back to project, I think it was 6, where we used play sound before. Use the same path you used when you created your own path there, and just make sure that the MP3 file is labeled correctly and it's actually in the same folder. And you should have no problems. So let's look at the Arduino code. Okay, so all of this is stuff we've done before. It's all stuff we've done before. What we want to do is we want to add a jumper to the LDR pin, which connects the LDR, light dependent resistor, to A3. And we'll set up our LCD, or set up our backlight. Incoming byte is used for communications back and forth between the Raspberry Pi without the Raspberry Pi and the PC. Hold and state are used for this and that. In setup, LCD begin 02, 16 characters, 2 lines. Clear the LCD, set up the backlight and turn it on. Print to the LCD, project 15, wait 3 seconds, and then set up communications between the Raspberry Pi without the Raspberry Pi and the PC. Make sure the baud rate is as seen here. Okay, our loop. State equals 0. We'll see why in a second. Clear the LCD, print to the LCD, waiting laser. Now this while loop, what it does is it waits for a laser beam to actually be actually beamed onto the light sensor. And I'll show you that in a minute. So this loop will go on forever until the laser is consistently on the light sensor. So while state is less than 100, it starts off at 0. Wait for 35 milliseconds. Hold, and then we'll take a sample of the LDR, an analog value from A3, and we'll place it in hold. If hold is less than 500, it means there's a lot of light on it. So add 1 to state. So if state was 0, now state equals 1. Otherwise, set state to 0. Why is this? Let's just say the beam was on the laser for a split second, like 200 milliseconds, and then removed. We don't want to save that information. We want to set state back to 0. We want the laser to be consistently on the sensor for 100 iterations at 35 milliseconds apiece. And once that's done, then the device knows that the laser is in place, and we'll say laser detected. We'll print to the second line of the LCD, awaiting breach. We'll wait 3 seconds, turn the backlight off, clear the backlight, or clear the LCD, and now we get another while loop here. While analog pin A3 is less than 500, digital write LCD enable high, which turns the backlight LCD on. Oh, sorry, I'm sorry, Mr. Derp. I forgot I didn't see this here. So this is its own while loop in itself. It's just, this is going to execute on its own. And while the light is still on the LCD. As soon as the light is removed from the light sensor, as soon as the light is removed from the light sensor, then the A3 pin will see more than 500, and at that point, that's a laser breach. And then we'll turn the backlight on, print to the LCD that breach is detected, set hold to 0, 0 print hold, wait 2 seconds and clear the LCD, and then it'll go back to the top here. So what's 0? Let's see here, back to the code here. If value equals 0, then we'll breach. Then at that point we've sent that we've received 0, and we will play the sound bite. So it's fairly simple. So let's look at the actual project. Some of you will have purchased a laser mount. It comes with mounting hardware and an Allen key to tighten everything. And what you want to do is, there's actually a sticker on the laser if you got a laser with your order, and just remove that because it makes it easier to add it to this. There we go, just shove her on in there. There we go. I'll add it here. Nice and tight. Now the battery box looks like this. Note the wires coming out this side. There's an empty slot here with a wire bypass. That's because I didn't have any two AA battery holders, and there's an on and off. So light sensor's right here, and you can aim this from across the room. The laser's strong. You can defocus and focus it by gently turning the head this way or that. Don't loosen it too much or else it'll fall off and the lens will fall out. So I've got the LDR jumper in place, and let's just see. Hopefully you can see that. I'm going to run the program, and then we'll line up the laser. And run. So it says Project 15, awaiting laser. So turning my laser on. Laser detected. Oh, sorry, my PC's plugged in. So let's do that again. Sorry, when I said my PC plugged in, I meant my earphones, so you couldn't hear it. So let me zoom out. We'll do it again. And on my shell, someone has breached the laser. So that's Project 15. Now there's other elements of this board that we haven't used, really, like the LCD. We haven't used the buzzer much, or the microphone. Those things are great for you to experiment with and use what you've learned so far to enhance. This board's completely up to you how you use it. You don't need to use this with Python. Think about it as its own Arduino unit. It has the capability to act as its own Arduino. So you don't need to actually interface with the PC. It's just that was the idea of the course. So I hope you got a lot out of this, guys. I really enjoyed working on this project, and I hope that you learned a lot. I hope that you realize the potential for this, because now you can use your own PC to create your own projects using external hardware. And you can experiment with different microcontrollers too. You can use a Raspberry Pico. It's a little bit different. You can, but I mean, now that you know how to do this, look it up on the internet. I've done it before. You can use an ESP32, or if you like, there's so many different options out there. And it's been a privilege. All of the packages are in the mail, so thanks again, everyone.